Hello PreCalc, how is our mighty six? We are looking at matrices again for the second time, and I've established three matrices which are arrays of numbers, and they are 2 by 3s. They don't have to be, but these are. And I want you to be aware that matrices are assigned a alpha name. So example A, B, and C. And usually indicate it with a capital letter. And I wanted to talk about some basics about matrices that you've heard before. And one of them is that you can add matrices if they are of the same size. So we could add A to B, because this is a 2 by 3 and this is a 2 by 3, by adding their corresponding values. So A plus B. Let's see what that would look like. So when I add A plus B, I would add 1 and -1, 2 and 2, 3 and 5, 4 and 7, 5 and 0, and 0 and 4. So easy peasy. All right, let's see if you can add A plus C and show me that you are watching this video and this video is not watching you. So add A plus C and tell me tomorrow what the answer is in your comp book. Put a little star by it so I can find it quickly. All right, then I'm going to go on to talk about another aspect of matrices. I'll try to keep these three in the screen. It turns out that matrices follow this principle as well. If you add A plus B plus C in this order, and you add them in this order, so this means I add B plus C first, and then take that result and add it to A. So this is do me first. And this one is do me first. So you do A plus B first, get that result and add it to C. You will find that these are equal. And that is called the associative property for addition. So now, in like manner, suppose we take a matrix like matrix A. Let me rewrite matrix A so it's in the screen here. I can take a constant, and I'll indicate a constant with a little c, and I can multiply C times matrix A. If little c happens to be a 2, that means I multiply every member of the matrix by 2. So I get 2, 4, 6, 8, 10, and 0 when I multiply each of these by 2. So that's a principle, and that leads us to this idea. If you take matrix, let's see, this is matrix A. Let me rewrite that without the little 2. 1, 2, 3, 4, 5, 0, and matrix B, which I called -1, 2, 5. 704. All right, it turns out that I also can take little c, which is just a number, it's not a matrix, it's a constant, and I can actually distribute that. So I can say C times A plus C times B. So there is a distributive property when you're dealing with a constant and two matrices. This result will match the same as if you add these two matrices first and multiply that sum by C. But here I am doing it this way, which comes in helpful sometimes. Matrix A, and every matrix has a additive inverse. The additive inverse is going to be similar to what we see in the real numbers. So let's grab somebody's thought cloud. Trent, let's see, when I said additive inverse, did not this pop into your mind? So if I'm adding a number to 4, its additive inverse is the number I add to 4 to get 4. So we also call it the, oh, I'm sorry, it's not the additive inverse. Sorry about that. You knew that, Trent, right? Additive identity. We'll get to inverses. So additive identity is what you add to 4 so you get the identical number that you started with. So the additive inverse, the additive identity is 0 in the real numbers. So when we add numbers, or when we add matrices, the additive inverse, the additive identity is the same size matrix as the one which we're finding the identity for, except every spot has a 0. So this is called the additive identity of this matrix. And as you see, if you add them together, you'll get what you started with, unchanged. So this is the additive identity. I'll end today with multiplication. So we can multiply matrices if they are like this. Suppose you have 2 rows and 3 columns, and you have another matrix that is 3 rows and 2 columns. You can multiply them if the number of columns in the first one is the same as the number of rows on the second. So if these numbers are alike, you can multiply them. Bad example, these two numbers do not have to be alike, but these do. So let me show you by example. A 2 by 3 can be multiplied by a 3 by 3. However, if I have a 3 by 4 and a 3 by 2, the columns and the rows do not match. So you would, if I asked you to multiply such matrices, you would say it cannot be done. Alright, so I'll show you. How about I'll do a 2, well you tell me, is this possible? Can we multiply a 2 by 3 and a 3 by 2? Alright, we already discussed that. So if those match, we can. So these outside numbers are meaningful. They don't determine whether you can multiply, but once you establish that you can, these are the size of the answer. So if you multiply 2 by 3 by 3 by 3, the resulting matrix is a 2-row, 3-column matrix. If you multiply 2 by 3 by 3 by 2, the resulting matrix is a 2 by 2. Let's try that one. I'll take a 2 by 3, and we'll say matrix, the first matrix is 1, 2, 3, 4, 5, 6. Two rows, 3 columns, 2 by 3. And I'm going to multiply that matrix by a 3 by 2. Say 1, 2, 0, 2, 2, 3. Alright, these can be multiplied because the number of rows in the first equals the number of columns in the second. The result, if I'm going to multiply these two, is going to be a 2 by 2. So I'm going to make that a little bigger just because I'm going to write some stuff in there. So let me move this over. Alright, so I'm going to result in a 2 by 2. So there's going to be a number here, 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 and here. Alright, so here's how you do it. You take, say I want to learn what goes in this one. Notice that is in the first row, first column. First row, first column. So I'm going to use the first row and the first column. The row coming from the first matrix C and matrix, and the column coming from the second matrix. Here's how the number, there's a formula and so forth, but I'm just going to show you the procedure. This times this plus this times this plus this times this. 1 plus 0 plus 6. You see where I got those numbers? 1 times 1, 2 times 0, 3 times 2. So that goes in here. It is a 7. Alright, now I'm going to go on to this one. Notice it's still in the first row, but now it's in the second column. So it's going to involve first row, and it's not going to involve this one. So I'll use a rectangle. It's going to use the first row and the second column, again, because this is in the first row, second column. Alright, and we're going to do the procedure again. This times this plus this times this plus this times this. Do you see that the numbers come out to be 1 times 2 plus 2 times 4 plus 3 times 3. And getting it in the screen, actually, it comes out to be 15. Alright, last row here, we're going to be in the second row and the first column. So we're going to use the second row and the first column. So when we do that, 4 times 1 plus 5 times 0 plus 6 times 2. And that comes out to be 4 times 0 is 0 plus, I'm sorry, it's 4 times 1. I was trying to write a 4. 4 times 1 plus 5 times 0 plus 6 times 2. 16. And lastly, let me see if you can come up with the last one. And again, that I'll check on video to see if you get it correct. Alright? See if you can take the method above and find the second row, second column entry, which will be the product, completing the product of these two matrices. So, it seems like something you would never ever use, but it comes up in lots of business applications, in computers. It's a simplified version. Suppose you have men's equipment and women's equipment, say bats, balls, uniforms, and I don't know, suppose the prices are thus. I'm just making that up. So, uniforms aren't usually that cheap. And say we have the cost of each, and in here, okay, this, I'm sorry, this, I know what I'm trying to say. This is the number. This is the number of balls that the women are going to buy. This is bats. This is the number of balls they're going to buy. This is the number of uniforms. This is the number of bats the men are going to buy, the number of balls the men are going to buy, and the number of uniforms the men want to buy. So now I'm going to put that together with the cost and say the bats are 21, like in the olden days, and the balls are 4, like in the way olden days, and say the unis are 30. So, how could you calculate the total amount? So you can take multiple, because this is a 3 by 3 and this is a 3 by 1, you'll see that we are able to multiply them, and we'll come up with a 3 by 1. And it will give us the total cost of the bats, the balls, and the uniforms by doing the multiplication the way I showed you. So that is just sort of an idea of a problem that you will see where you need to multiply matrices. And of course, a problem this simple, you wouldn't really set up a matrix, but if you had a vast number of columns and situations, you could get a machine to do that, the good old computer, and it would be very helpful. Alright, with that inspiring example, have a nice evening or day, depending when you're watching this. Alright, carry on.